Mobile anti-distraction application for motorists using C4.5 algorithm. Background of the problem. Different technologies have emerged in today's world. The start of portable computers, laptop, tablet PC, and smartphones have made mobile computing very convenient and have helped the lives of people with the phone's features and applications. Smartphones have the capability of running multiple programs concurrently or run background processes which make mobile computing change the landscape of people's daily life, like using short messaging service, SMS, multimedia messaging service, MMS, phone, email, web browsing, and many developed programs and application. Smartphones have gained large market shares among various user sectors due to the usefulness, ease of use, and affordability which make these devices easy to use everywhere, by everyone at all times. Gartner, a technology research company, predicts that intelligent apps will be one of the top 10 strategic trends for 2017. Mobile is now an ideal platform for artificial intelligence or AI apps because of varying array of personalization capabilities. Smartphones are aware of user location and user behavior. AI capabilities are being built into mobile apps of all kinds, making them contextually aware of user behavior. These technologies can be used to learn users' behavioral patterns to make each app session more valuable than the last, increasing overall retention rates. The awareness of Android applications to users' location and behavior can be supported by smartphone sensors. Smartphones are equipped with different sensors depending on the phone model. The Android platform supports three broad categories of sensors: motion sensors. These sensors, which include accelerometers, gravity sensors, gyroscopes, and rotational vector sensors, measure acceleration forces and rotational forces along three axes. Environmental sensors. These sensors, which include barometers, photometers, and thermometers, measure various environmental parameters, such as ambient air temperature and pressure, illumination, and humidity. Lastly, position sensors. These sensors, which include orientation sensors and magnetometers, measure the physical position of a device. These sensors make smartphones powerful. News Bites Philippines, an ICT news website, tells that Filipinos are greatly attached to the usage of smartphones for varying reasons, whether communication, entertainment, or productivity. This statement is proven on its infographic article entitled Profile of Smartphone Users in the Philippines, posted on September 26, 2016, which states that Philippines is the third largest and fastest growing market for smartphones in Southeast Asia. It also reveals that smartphone ownership among Filipinos is in 3 out of 10. In terms of usage of smartphone, Filipinos spend 3 hours and 14 minutes as average daily use of the internet via mobile phone, 78 minutes per day for entertainment-related content, 56 minutes per day on applications use, and 40 minutes per day in communication services. Due to smartphone use as part of the lives of the Filipinos, the use of it while driving is a growing concern to road safety nowadays. Road accident is one of the reasons of deaths across the globe, with a yearly approximation of 1.25 million people. The risk factors of these incidents are human error, speeding, driving under the influence of alcohol and other psychoactive substance, non-use of safety measures, helmets, seat belts, and others, and distracted driving, which is caused by mobile phones. According to Philippine Daily Inquirer, the data from Philippine National Police Highway Patrol Group, PNP-HPG, revealed that in just first 4 months of 2016, 10,656 vehicular accidents in whole country, resulting in 549 deaths, has been already recorded, which are very alarming. As an answer to this fatal incident that distracted driving can contribute, the Republic Act 10,913, or the Anti-Distracted Driving Act, ADA, is implemented to prohibit activities which included but not limited in making or receiving calls, writing, sending, or reading texts, based communication, playing games, watching movies, performing calculations, reading ebooks, composing messages, and surfing or browsing the internet. Due to the need of motorists to bring smartphones while driving, it gives the researchers a chance to develop an Android application that will assist motorists in the use of smartphones while on the road. Thus, the motorists can prevent distraction from using smartphones. Statement of the problem. Anything that takes the attention away from driving can be a distraction. Sending a text message, talking on a cell phone, and using a navigation system are a few examples of distracted driving. Any of these distractions can endanger the driver and others. There are 3 main types of distraction: visual, taking eyes off the road; manual, taking hands off the wheel; and cognitive, taking mind off of driving. The use of smartphones is on the daily life of Filipinos, including driving, which causes distraction on motorists. World Health Organization, WHO, in its 2015 Global Status Report on Roads, said that distracted driving is a serious and growing threat to road safety. The WHO also said that drivers talking on a cell phone are 4 times more likely to get into a crash than a driver who is not on the phone. In order to know the smartphone activities of the motorists while driving on the road, the researchers conducted a survey to 200 participants composed of public and private utility vehicles. Smartphones that operate an Android lollipop dominated the smartphone operating system from 36% of the motorists. Family member tops as motorists frequently received calls by garnering 56.5%, and the same contact attains the same percentage, which is 56.5%, as frequently received SMS. In responding to received calls and SMS, while on the road, 54.05% of the motorists answer calls or call back only when they reach their destination, and 66.31% reads the message only, also when they reached their destination. Aside from basic communication services that smartphone offers, calls and SMS, the motorists play music from their smartphones. Even though RA 10913 prohibits the use of mobile phones while driving, Anti-Distracted Driving Act allows the use of electronic devices, but motorists should pull over to a safe spot or hands-free use of a cell phone through an earpiece or an in-car microphone. Pulling over to a safe spot is sometimes not a good choice for motorists who are in a narrowed lane road or in a hurry, so some of them who can avail hands-free devices like headsets, stereotype headsets, or car itself, which has in-car headsets powered by Bluetooth, use them to accept calls, but these devices are costly and battery inefficient for smartphones. To avoid these money and battery costs, the motorists may only rely on smartphones' resources like its built-in sensors to avoid distractions and at the same time, to assist incoming calls by using speech recognition. Objectives of the study. The general objective of the study is to develop an Android application that helps motorists to comply with Anti-Distracted Driving Act through hands-free management of calls and SMS they received while driving. The study specifically aims to develop an Android application which allows users to switch between two modes to activate driving mode and to return in normal mode. Manage calls using speech recognition when phone is in driving mode, and let the application to read aloud received SMS using text-to-speech when phone is in normal mode. Prioritize calls based on users' priority contact list, and inform phone callers and SMS senders hands-free that the motorist is driving a motor vehicle through SMS. To implement C4.5 algorithm in generating suggested priority contacts to help user in choosing contacts which may be important. To use Android Studio in developing the Android application, SQLite for database, and Adobe Illustrator and Adobe Photoshop for editing images. To perform alpha and beta testing to test the application. To evaluate the Android application using ISO 9126. Scope and limitations. Get users of the application are motorists. By using smartphone's accelerometer to detect the changes in the acceleration of the device, the application will automatically activate driving mode, but this function should be enabled. The user has also an option to activate it manually by tapping the activation button before driving the motor vehicle. Normal mode is the state when the users are not in driving mode. In this mode, the users must select priority contacts in the contact list, or they may choose on the suggested priority contacts that are generated by the algorithm. Users must also add predefined SMS with a maximum of 9 entries. Motorists can also edit and delete predefined SMS, add, set, and remove music and navigation applications. They can launch music and navigation application that they set as default only in normal mode. This mode performs also reading of received SMS using text-to-speech, but this function should be enabled. If enabled, the application asks the users if they want to reply to the received SMS after reading it to them. The application recognizes yes and no voice command. If users answer yes, the application will read the predefined SMS that they may reply with its corresponding assigned number. The users can choose which predefined SMS to send by saying the corresponding assigned number of the predefined SMS. In driving mode, Madam is pinned in the screen, therefore, the launching of other applications is prohibited, but the use of navigation application is allowed provided that it is set as default in the navigation application list of the proposed application. In using the navigation application, the location must be set before driving. In assisting calls and messages, it informs the motorists about incoming calls from priority contact by using text-to-speech and speaking the caller's name. The application will ask if the call will be accepted, so by reciting yes and no voice command, it can answer or decline calls. Calls from non-priority contacts are automatically declined, but an auto-reply message will be sent to the caller. To confirm if the call is an emergency, the blocked caller may call again 3 times, then, the call from them will notify the users. However, the application is subject to limitations, such as the application runs only in Android smartphones running an Android Lollipop and above. English is used as a language in text-to-speech and speech-to-text. The accuracy of the recognition of speech-to-text can be affected by background noise and depends also on the user's voice clarity and distance from the smartphone. The smartphone's accelerometer is device-centric, according to manufacturer. Therefore, the accuracy of the acceleration values differs from device to device. The application bases only on change of. The researchers assumed the following. The user allows the Android application's permissions for smartphones running in Android Marshmallow. The installed Google application supports offline speech-to-text function. The user has prepaid load balance or registered to text promos to send SMS. The smartphone is placed within 4 inches from the dashboard or within line of sight as prescribed by the law.